GeopByte.
Let us take the another important problem. Look at this problem. Asking like this. A car starts from rest and accelerates at 5 meter per second square at t equal to 4 seconds. Okay. Car starts from rest means initial initial velocity of car, that is u equal to 0. After t equal to 4 seconds, the acceleration of the car equal to 5 meter per second square. Okay. A ball is dropped out of a window by a person sitting in the car. After 4 seconds, ball is dropped by a person who is sitting in the car. What is the velocity and acceleration of the ball at t equal to 6 seconds? That means what is the velocity and acceleration of the ball, right? Falling ball after 6 seconds. Okay, that is the question. Okay, for that, as you know, the car, velocity of car after 4 seconds equal to v equal to u plus 18. Here, what is the initial velocity of the car? Initial velocity of the car u equal to 0. Then v equal to 80, a equal to 5, t equal to 4. It is 20 meter per second. Okay. Then what is happening? A ball is dropped. A ball is dropping down means a equal to g plus g. Let me write it clearly. A equal to plus g, because the ball is falling in the direction of gravity force. That is equal to 10 meter per second square. That is the acceleration. Look at the options. He is asking velocity and acceleration. Acceleration is given 10 meter per second square only for the option C. Option C is absolutely correct. Okay. So by looking the right answer, you can come to know the answer, because the acceleration is given 10 meter per second square only with the option C. Okay. Now we can also find the velocity. You know, velocity, horizontal component of velocity. Horizontal component of velocity, horizontal component of velocity of the ball is equal to velocity of the car only. Velocity of car. That means horizontal component of velocity Vx equal to velocity of the car. That velocity of the car you decided 20 meter per second. Okay. Now vertical component of velocity. Vertical component of velocity of the ball. Vertical component of velocity of ball Vy equal to Uy plus Gt. Okay. Here it is dropping Uy equal to 0. That is equal to Gt. Here it is asking what is the velocity after 6 seconds. This is the velocity of the car after 4 seconds. After 4 seconds. Then vertical component velocity after 6 seconds means here t should be 6 minus 4 equal to 2 seconds. It is equal to 10 into 2, 20 meter per second. That means horizontal component velocity and the vertical component velocity remains same. Then the net velocity v equal to root over vx square. Net velocity of the ball vx square plus vy square. It is equal to root over 20 square plus 20 square is equal to root over 2 into 20 square. Let me write it clearly. 2 into 2 into 20 square. So it can be written as 20 root 2. That is the velocity of the net velocity of the ball with acceleration 10 meter per second square. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, look at the another important problem. Look at this problem. It is asking like this. A person standing on the floor of an elevator drops a coin. Drops a coin means initial velocity of the coin. Initial velocity of coin u equal to 0. The coin reaches the floor in time t1 if the elevator is at rest, and in time t2 if the elevator is moving uniformly. Okay, you know the distance traveled by the coin, vertical distance, because the coin is dropping down. Vertical distance traveled by coin equal to h equal to ut plus half into gt square. Since it is dropping, initial velocity 0, then h equal to half gt square. Okay, h equal to half gt square. From this I can write that t square equal to 2h by g, or t equal to root over 2h by g, or t is directly proportional to 1 by root g. Okay, na? Because h remains constant. H remains constant. Now, from the floor, from the floor, the coin is taking the time t1 is proportional to 1 by root g. Okay, while while the lift is moving, while the lift is moving uniformly, uniformly, relative acceleration g dash equal to g plus or minus a. But lift is given traveling uniformly means acceleration a equal to 0. If acceleration is 0, g dash equal to g only. Then from the lift, the time taken is t2 is proportional to 1 by root over g dash. But here g dash and g both are equal. Therefore, the time required for the coin while it is dropping from the floor is equal to time required for falling down the coin right from the lift. T1 equal to T2. That is the answer. Look at the options. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A person traveling in a straight line moves with a constant velocity v1 for a certain distance x, and with a constant velocity v2 for the next equal distance. Let us take the total distance from A to B. The total distance is 2x. Okay. Let us mark the point at the middle. C. AC is such that it is equal to CB. That is equal to x, because it is clearly given that for the distance x it is traveling with the velocity v1, and with the velocity v2 it is traveling the next equal distance. That means this distance equal to x, this distance also equal to x. But for AC, for covering the AC, velocity of the person is v1, and from C to B velocity of the person is V2. Then the average velocity V is given by the relation. You are asked to decide average velocity. Now let us decide the time required. Time required for covering the AC. TAC equal to distance divided by velocity. Similarly, time required for CB equal to distance divided by velocity V2. Okay. Then the average velocity V average equal to the total distance divided by total time taken. Total time taken. Okay. Then V average is given as V. Total distance equal to what? X plus X. 2x divided by T for AC plus T for CB. Okay. Now the V equal to 2x divided by, look at the time required for AC. It is x by V1. For CB it is x by V2. Okay. It can be written as 2x by, let us write the x outside. It is 1 by V1 plus 1 by V2. Now here x is cancelling. X is cancelling. The average velocity V equal to 2 by 2 by 1 by V1 plus 1 by V2. From this I can write that V by 2, otherwise 2 by V by 2 equal to, otherwise 1 minute. Let us write one more step. 2 by V2 plus V1 by V1 V2. From this I can write the V by 2 equal to V1 V2 by V2 plus V1. Right? That is the relation. Now look at the options. Look at the options. It is given 2 by V. It is given 2 by V. So from this particular relation, I can write that 2 by V equal to 1 by V1 plus 1 by V2. Okay, that is the relation. 2 by V1, 2 by V equal to, look at the option B, 2 by V equal to 1 by V1 plus 1 by V2. Therefore, option B is absolutely correct. Understood clearly? This kind of problem is repeating frequently, correct? Almost similar problem. This is the third time so far I have been discussing. Okay. Similarly, that means from this I can say that this kind of problem can be repeated. It is a 5-star problem. Okay, 5-star problem means chances are there for repeating the same problem or similar problem. Okay.
GeopByte.